the Australian Electrolysis Committee. It's being hailed as a May Corrosion Spectacular, and thanks very much to the ACA and the Victorian branch for helping get all this organised. I'm Bruce Ackland. I'll be chairing the meeting. We've got Lachlan Sevens from the ACA as the host. He's in control of the webinar levers, and Ali Cookland from Mondo is our hardworking secretary of the AEC. They'll be tracking our progress. So, opening slides, you should see that there, just indicating, well, it's the joint meeting, and is in fact the 86th meeting of the Australian Electrolysis Committee. Now, over the years, we've had various obstacles placed in our way, and most notably was in 2011, there was the volcanic activity in Chile, for those of us old enough to remember that. Well, we defeated the volcano and we still had our meeting. It was a delayed by a week, but we had a meeting in Launceston, and it was a particularly successful meeting. It was good fun, and the volcano provided us a little bit of entertainment along the way. This year, of course, we've got the coronavirus responsible for the COVID-19 disease. Well, bad luck virus, because here we are. It seems like nothing can stop us. So we're at the 86th meeting of the Australian Electrolysis Committee, and of course we're having it in cooperation with the Vic branch, which is terrific. So just a brief history of the AEC. So the first meeting of the AEC was held in November in 1977 in Brisbane. And it initially consisted just of members of the various state electrolysis committees, so the official electrolysis committees. The meetings were held consistently for twice each year since then, and we had a first draft of a constitution in 1980, and the membership was then extended beyond the electrolysis committees, and so now basically anyone that's on Ali's email list is a member of the AEC. We're here to disseminate information and knowledge about anything to do with electrolysis. And by electrolysis, I just mean corrosion is one form of electrolysis, but basically anything to do with current through the ground or soil or water causing chemical changes. So today is the 86th meeting and celebrating 43-year history. I'm going to go through the agenda very quickly, me opening the meeting. The second speaker, or the first official speaker, is Alan O'Connor, and thanks, Alan, for joining us from all the way from New Zealand. We've got Ramon Salazar from SA Water, Jim Hickey from Ausgrid. Now at midday, there'll be a little chance for a bit of a refreshment stop. We're going to have a general discussion, and we're going to keep any questions going that we can, and any discussions. And we're going to have the AEC annual general meeting, which is a very quick affair where we just vote for the chair and the secretary's positions, have a general discussion on the next meeting, and then we'll move on. And at 12:30, we'll try to be quite punctual. We'll reconvene. If anyone's still out of the room, you've got to come back into the room, sit in front of your computer, and we've got Richard Broderick will be giving a talk, and then Wayne Burns at 12:45. A couple of little tips on the protocol for the meeting. It's a first for a lot of people and a first for a lot of us. But the speakers will have control of their screens and the presentations and audio. Now, the audience, and I'll have a look at it in a minute, but we're up to probably about 80 odd people who are listening in to the presentations. You can pose the questions by using the Q&A button down at the bottom of your Zoom screen. And the audience won't have access to the microphone because there'll just be way too many people all jumping in. It'll just be bedlam. So only the presenters and Lachlan will have access to the microphone and overall control. But please send a question in, and the presenters at the end of their presentations will be reading out the questions that they've got time for, answering them, and we'll encourage you to, if you have other questions, just contact the person after the meeting or in your own time and continue the discussion. Because the whole idea of the AEC and our meetings is really that dissemination of knowledge and sharing of information between interested people. So let's begin. Our first speaker, and I'll introduce each speaker. Oh, shush. I'll introduce each speaker in turn, and I'll read I'll do a quick read of the bio. So our first speaker is Alan O'Connor. He's the New Zealand manager of CCE, Corrosion Control Engineering, in sunny New Zealand. Now, okay, bio. Alan is the New Zealand manager and senior corrosion engineer based in New Plymouth. He has a Bachelor of Mechanical Engineering from University College in Dublin and has 14 years experience in cathodic protection. Alan started his career in 2006 when he joined CCE's Sydney office as a graduate engineer. In 2013, he joined APA Group as the New South Wales corrosion engineer, looking after CP on 4,000 kilometres of pipelines, including the 1,300 kilometre movement of Sydney pipeline. It was APA that Alan, with APA that Alan installed the first fully remotely surveyed pipeline cathodic protection system in Australia. Alan rejoined CCE in 2018 to take up the role he's in at present as the New Zealand manager. Alan's been involved in all aspects of cathodic protection, including design, installation, commissioning, troubleshooting, routine maintenance, and integration with asset management. So with that, I'm going to sign off and hand over to Alan. Now, and if I hit stop share, it should be over to you, Alan. Okay.
Okay, can everyone hear me? Fantastic. Thanks for the intro, Bruce, and thanks for everyone for coming along. I guess look, I got a short notice call up here, and I thought that what people might find interesting is my experience between working in Sydney and doing some work that we've just started down in Wellington. It's really good to see a few familiar faces and names through the attendees list here. I'm sure we'd all much rather be in the same place and share a brew afterwards. But anyway, this is how it is. So we've got some nice pictures here. We can see Sydney on the left, of course, and my main. Oh, I'll just pop backwards. We can see quite a lot of rails there. They've obviously got quite large trains, double deckers, quite a lot of trains, quite a lot of stops. It's reasonably flat though, in contrast with Wellington, which we see on the right. Now the inset picture on the top is a cable car. That's not what we're calling a train over here. Look, there's a lot of single track rail and a double track rail on the main line. So in Wellington, we've got less rail, but there is a lot steeper, so we do need a lot of power. We know from Kiwi Rail that with the distribution of substations at the moment, they can't pack as many carriages as they'd like to. And I think probably something that's interesting in Wellington is that the Kiwi Rail own the track, Wellington City Council own the trains, and then it's operated by Metlink, so it's not as consistent as Sydney Trains is. Right, so what does that mean for pipelines? Well, I'm sure we've all seen graphs like this before. Just a couple of notes here. So I'll open it up to guesses as well. If anyone wants to guess which is which. The black graph is from 0 to -3 volts. The blue graph is from +3 to -7. So there's quite a difference in the scale of traction. I usually try and define the scale of traction as the difference between the 5th percentile and the 95th percentile. So that generous middle portion of the bell curve, so to speak. For the black graph, that's about 750 millivolts. And for the blue graph, that's about 3.5 volts. So same pattern, different magnitude, and the big difference in this case is, in my opinion, it's going to be rail to earth resistance. So I haven't seen on my screen any guesses come up, but just to clarify if anyone has, so the black graph is from Sydney and the blue graph is from Wellington. And probably the easiest way to check that out is you can see the quiet time overnight in Wellington, and they've got a much better work-life balance there. and they go to bed at about midnight, and they don't get up again to go to work until 6 o'clock. So if the traction effect is pretty similar, where does that leave us as people operating cathodic protection systems or being responsible for asset integrity? Well, if you're in Sydney, you would have the Australian standard to work to. You'd have a regulated electrolysis committee that meets monthly. And as Bruce sort of mentioned before, my experience with the New South Wales Electrolysis Committee was one of great education. At the time, Peter Hosford was the chairman, and he always made sure that there was plenty of spare time at the monthly meeting where a young engineer could ask one of the older guys, what's your opinion on this, or how did you do that? And when it got to the field, everyone else was just as friendly. So in New Zealand, we don't have a dedicated New Zealand standard, and we don't have a regulated electrolysis committee either. So that puts us at a slight disadvantage. Bruce again mentioned the number of years that the AEC has been going for, and what I've got here on the left is the New South Wales Guide for Measurement of Interference, which I guess is known as the Red Book, and the Victorian equivalent as well. Now, both of those are 100 pages long, and there's a lot of information there. And again, if you're young, if you're starting out and you're curious about this stuff, there's some great information there. And we don't have that at the moment in New Zealand. So that's just another interesting comparison. And by comparison, the 2832.1, I think, is 114 pages. I'm sure some of you will be familiar with this. Some of you won't. We've got, a conductance chart, a correlation chart, and an interference chart. And this charts would have been supplied by Sydney Trains. So they obviously had the chart recorder there and available for use. And look, I was always amazed by how they could draw a straight line through some of the red squiggles, but all credit to them, they did, and solved a few arguments on the way. Probably the interesting thing to point out as well is you've got all the asset owners here. You've got telecommunications, you've got water, electricity, distribution and transmission gas, all attending for a test. So that's something that isn't quite up and running just yet over in Wellington. But what we have got, and this is, I guess, where remote monitoring comes into it, is we've got a great opportunity with some newer technologies. So we've put some remote monitoring in on the Wellington system, and that's allowed us to track the pipe potential over time. What the Sydney and the Victorian systems really give you is a really excellent picture of what's happening on the day that you do the testing. But as soon as you pack up your gear and you move off, well, things could change that you aren't seeing. And this is where remote monitoring can really add some value. And in terms of learning as well. So we spoke about the electrolysis committee being a place to share information. When I was in Sydney, I was learning from Bruce Flack for a few years, and I realized that Bruce had been undertaking 4 surveys per year on a pipeline affected by traction, and the pipeline was about 20 years old. After about a year of operating remote data logging, we realized that we had exactly the same amount of information as had been gathered in the same 20 years. Now, we weren't able to match that with the same analysis time, but it does give you the opportunity to learn quickly, because really the largest variable is going to be your rail to earth resistance, and you need to be able to figure out where that's reducing or what the trend is. When it comes to operating a traction affected system. You know, remote monitoring is a new technology and remote control is a new technology. You still need to get yourself one of those people in the middle there called a corrosion engineer to put it all together for you. You know, just load them up with responsibility, as we do. But you know, none of the systems are going to drop you out an answer that meets directly up with the Australian standard. There still needs to be analysis and learning and all opportunities, you know. So in practice, you know, Bruce would always tell me, you've got to build up a picture, Alan. I'd be trying to make a conclusion maybe on one or two results, and he'd want a bit more. So bringing us back to the start, I talked about defining traction as the difference between the 5th percentile and the 95th percentile in your 24-hour chart. So the chart we're looking at here in the background, so the blue line is the 95th percentile and the red line is the 5th percentile, and this green line is the difference between the two. So fault finding by magnitude is I guess pretty routine for us. You know, where is the traction effect the biggest? Well, the fault must be close to there. And with remote monitoring, we can see the inset chart. We can go to the location of the greatest magnitude of traction, and we can see when that started. So we can see there about 7 o'clock, there's a big increase in pipe potential and potential variations. So that makes managing the system a lot easier. There's lots of ways. Of course, the rail to earth resistance can reduce, and that's what a lot of this game is about. So obviously on the left there is one of the sort of lesser expected shorts we had, and we were able to find that within about 2 or 3 days, which is pretty good compared to what it would have been on 4 surveys per year. And you know, really what it takes when you're trying to operate a traction affected structure is people who wear orange vests and who get out into the field and they reset the spark gaps and they find things like we have there on the left. And our role is to really facilitate those people and help them out. So all credit to them. That's what we're looking for. I just wanted you to give a quick rundown of remote monitoring. I can see I'm getting tight on time here and I want to allow everyone some questions. So when we evaluate remote monitoring and what we want to use it for is really key. And I just see a lot of products in the market, and it's really good because you know, everyone's taken their own understanding. They're all slightly different. There's probably a perfect product for what you need. But my main criteria is I ask myself, is this going to be around in 10 years? Because when I first started, I had to use some data loggers that ran on MS-DOS, and a special computer had to be used because they're so outdated. And I really wouldn't like that to happen to any of the remote monitoring systems I've installed at the moment. So my advice on the remote monitoring is to really go with the tried and tested, and you know, just be wary of the latest and greatest. You don't want to end up with a DVD player or a Blu-ray player when everyone's streaming. So with that, I'll end the presentation and I'll open up for questions and answers. So I'm not actually sure how to see the questions.
Okay. Okay. Alan, it's Bruce Ackland here. Can you hear me?
Yep.
Okay. Well, we stream to everyone. If you scroll down to the bottom of your screen, you should see a Q&A button.
I've just found it, and yep. Nick Doblo, yeah, congratulations, you got that right. Yeah. Candice, I can send you through a copy of the Red Book, or I'm sure Jim Hickey would be more than happy to.
Just read out the questions too.
Sorry, yeah. Nick had confirmed that Wellington was the blue graph on the slides. Candice, good to hear from you. She wants to know where to get a copy of the red book. So look, if you email me, you can get one. Jim Hickey, I think you're the chairman at the moment. I'm not sure if there's been any revisions since I was there. I'm sure Jim would be happy to share it with you as well. Peter Dove, mobile office. Yes, we've just come out of level 3 restrictions in New Zealand, so the whole company is trying to get started again. So that means that yes, we're all doing maybe 2 or 3 things in a day rather than just 1 or 2. What sort of remote loggers and software do you use? Look, I've used a lot. I've used the Corrosion Electronics TrueView. I've used the Aegis data loggers. I've used the Wileki's data loggers. And look, like I said, they've all got pluses and minuses. If you want to talk to me directly, if you're thinking about getting some yourself, look, contact me directly. I've got lots of opinions on it, and maybe I can point you in the right direction or help you out a bit. And Luke's mentioned what sort of reference electrodes do you use for remote monitoring? And I know Ramon's gonna get into that topic. And yes, remote monitoring makes reference electrodes much more important. When we were on a long pipeline in Sydney, what I found was that our references, the zinc references, were reasonably stable, but also you do get, as you get to know your structure, you might find that you know, as one reference drifts, it'll become obvious in the data that it's one reference at one location drifting rather than a problem at that particular area. So it's a little bit how you use them, I suppose, as well. And we've got, hi, Owen, what about the Internet of Things for CP monitoring? Could you share your experience, please? Look, I let the remote data logger people do their thing. You know, software is huge. Anyone, I think, in the industry has used some pretty outdated loggers in the past. You know, I guess we're touching on everything has a SIM card now and a modem. And, you know, the question I sort of ask is, are all those things going to be around in 10 years or 20 years time? Yeah, sampling rate, Rajko. So the sampling rate is usually a trade-off with battery life. I think we dropped back to 10 minutes and found that at a 10-minute sampling rate, your 5 and 95 are still extremely close to at a 4 times per second sampling rate. And determining the 5 and 95 percentile, we just use the percentile function in Excel to do that on a set of data. So the difference between percentage and percentile is the it's a sort of median versus average. If you give it a quick Wikipedia, it'll give you some good detail there.
Okay. Oh, I'll put myself on as well. All right. Well, look, I think it's almost time for the next speaker. So, look, that was terrific. Thank you very much, Owen. And I'll let you know that at the moment we have 99 participants. Just need to encourage all your friends to get that one more there and we'll get to 100. So, you know, keep the questions coming to the panelists. You know, there are a lot of people viewing this, so there's a lot of interest in it, which is really, really, really good. So thanks again, Owen. It's great.
Okay, thanks, Bruce. Thanks, everyone. Okay,
I'll introduce our next speaker is Ramon Salazar from SA Water over in Adelaide. Ramon is the Senior Materials Engineer at South Australian Water Corporation, SA Water. He's more than 25 years experience in corrosion control field, focusing on cathodic protection, concrete degradation, and non-metallic materials. He's currently the chairman of the South Australian Electrolysis Committee. He has an engineering degree from Simon Bolivar University in Venezuela and is a chartered professional member of Engineers Australia. He's also NACE CP4 cathodic protection specialist. So Ramon is going to talk about permanent reference electrodes and are they reliable? And it's something that I think there'd be a considerable interest in. So Ramon, I'll hand it over to you. Thanks very much. So you should be able to have control of the screen.
All right, thank you. Good enough. So now, sorry. All right, let me share screen. All right, can you see? Okay, I'm going to talk about the permanent reference electrodes. So the question is, are they reliable? So this is a question probably I think about as a working out for like operating company. So first of all, I'd like to say, okay, why do I need a permanent reference electrode? Well, in my case, I'm talking about only direct burial, so not talking about concrete or submerged structures. So in this case, so number one, we use it for remote monitoring. Just basically, I just want to get the readings. Probably if I don't have enough resources to send people to take readings, so if I can get information from the system, which would be good. The other thing is I can use it is for potential control mode. So I just want to set up potential certain level and say, for example, minus 1.2 volts and ohm, and then just the rectifier will start working that level to maintain the level. Now, in our permanent reference electrodes, supposed to be permanent, but obviously they have a limited life. And then they have some issues that can affect the life of the reference electrodes. One, for example, is if you have the porosity of the porous plug, obviously you have contaminants that can enter the reference cell, like chlorides in the case of copper sulfate reference electrodes. Obviously can contaminate the reference cell, or in the case that the copper sulfate copper ions can leach out of the reference cell, and then the reference cell is not saturated anymore, and so you don't get correct readings. The other things that can affect reference electrode is the distance from the structure. So if it's too far away, you can have some errors, can add to the reading. But if it's too close to the pipe lamp or a coupon, probably you can have electrode deposition of copper onto the pipe lamp or the coupon. So probably changing the metal soil interface. The other one is when soil gets dehydrated, in case it's too dry, so there's no electrical path to take the reading. So, but once the moisture comes back, the reference electrode should reactivate. So probably I would be more concerned about the third one, because we have experience in South Australia, so it's just dry soils, and they can affect the life of the reference electrodes. Yes, I'd like to talk about what are the issues we could have as water. So we have a lot of trunk water mains buried on the busy roads. You know, in the city, probably sometimes you have really deep, for example, sewer mains or different pipelines. So if I have a reference cell next to the pipe, so it will be under the road. So if I need to replace it and I need to work at night, traffic management, etc. So there's a lot of money. And for example, in this photo is you see this is King William Street, and then you have the tram line here, the dashed line, and so you have a water mains here, blue lines, and they're parallel to the line. So this is a good example. I could use automatic mode, the reference cell, but if the reference cell fails, so then the system or the whole thing fails. So I think it's important that we are confident about a reference cell in the area. We started to hear from CPTEX. Here is a water that they say that they started to see some of the reference electrode stopped working. And they claim that probably that's because they dry out. And for example, this is data taken from SCADA. At that point, for example, I picked one day, 13th of May, the potential recorded by the reference electrode is minus 0.17 volts. However, the latest survey that was, I think, in February, it was on and off. It was it's only ohm, 977 ohm. And they used the portable reference electrode, minus 1.0 40 volts. This manual reading is, they took the reading directly from the reference cell on site. And this is another example, and another water main. So the reference electrode is measuring minus 0.13 volts, but the latest survey, it was 0.893 volts on, 0.620 volts off at that particular location. So obviously this 0.13 volts is really, really far from the point. And then if you see that there's like a straight line here, doesn't have much change. So then the question is, what's going on here? Is it just because it's dry out? Can we reactivate the reference electrode, or is it, or there's a problem with probably broken cable? So that's why probably we need to investigate on this. So one of the things is thinking about reactivating the reference electrode if it's in the middle of the road. So one of the contractors did this following installation. So they brought because the reference electrode is under the road, so you have this road chamber, but because you don't have access to that, because you will need to set up traffic management. So then you had to bring the reference electrode to the footpath. So they came up, installing like a PVC pipe going from the test point on the footpath, and then to wet the reference electrode. So then basically you come from the road, for example, this photo at the bottom. So you see the open PVC pipe. So you pour water in and you could reactivate the reference electrode. However, if you see, is it something that I need? Isn't it making it more expensive or more complicated the system? Because one of the recommendations obviously is that it would be good. So you would put a PVC pipe, and then you can get access to the reference electrode, or you can water, or you can insert portable reference electrodes if you want to calibrate. But in this case, it's not accessible because it's in the middle of the road. So then I started to wonder, what should I do if I want to keep my reference electrode wet? I know in the past, still some suppliers are still selling reference electrodes in a bag, for example, with a backfill, like bentonite backfill. So the primary purpose of the backfill is low contact resistance, and retain water. Now, for we are not using that kind of reference electrode, so we just use the reference electrode in native soil as recommended by the manufacturer. Now there's, in terms of evaluation of reference electrodes, we have in NACE have a TM0211, and they provide a method to evaluate the durability of reference electrodes. However, they measure is the copper sulfate leaching out of the reference electrode or chloride contamination. However, they say in section 1.4 that there's they are not measuring the tendency to dry out, so it's not addressed by this test method. However, found one of the papers from a conference, NACE conference in 2001, prepared by a team from Corpro. They measure the dry out tendencies of copper sulfate, and determining what that would dry out quickest. What is the dry? How quick the reference electrode dry out in some sand or arid environments, how quick they can regain functionality again. Other options, so can we explore other options of maybe more stable or can last longer? So can we use, for example, zinc reference electrode, high purity zinc, for example, packed in a with backfill? Or can we use zinc sulfate electrodes or palladium chloride electrodes, or any new development, for example, new technologies or ways of measuring corrosion or potential? Or or the other option is do nothing, just rely on annual survey and only use portable reference electrodes. The problem with this approach is if you have a limited resources, for example, in Nesa Water, we have 4,500 test points, so which is a lot of work. And then it's basically, that could be a problem. But if you can find a way that you use some reference electrode and then you are reliable, so you don't need to replace them in 4 or 5 years, so that will be good. The thing is, I have to just clarify is that the reference electrodes, not all of them fail after 2 or 3 years. So some of them have been installed in the past 4 or 5 years, are still working very well. Actually, we haven't conducted a investigation of why the reference electrodes are failing in 2 or 3 years. And probably one of the things I would like to do is say, look, if it's dry, because they dry out, so if I pour water, I pick up some 3 or 4, and then use the data logger and measure how quick they can regain functionality, if I can reactivate them, or check, maybe it's not a problem with dry out reference electrode. Maybe it's the cable. Once in Port Lincoln, I found there was a reference electrode. It was not measuring anything, and so I went to because there was a box. We use a plastic box where we connect the reference electrode, and then from there run all the way to the rectifier. And I found that it was corroded, and so we had to replace or splice again the cable, and then started working again. So that could be another possibility. And I think it's we need to think if that's the case, or thinking about using other type of reference electrodes. So I think this is it for today. So you have any questions, I'll be happy to answer.
Okay. Now, Ramon, there's a couple of questions on the Q&A. If you click your Q&A button, there's some questions from
Okay,
Candace,
Q&A.
Robert Cox did have a question there that's disappeared, and
Okay.
Rako. Otherwise, I can read them out to you, and you could respond.
Yeah. Okay. I'm reading Candice.
Yep.
She asked, "Why don't you use the bentonite bag?" Well, actually, we're using this Borium Stealth 2 reference electrode, and just read they say no, don't use a bentonite bag. So use the native soil. So apparently, the plug retains or supposed to retain moisture, so they don't recommend to use the bentonite bag. So basically, the contractor just follow the instruction of the so I'm just wondering if that could be a problem, or maybe we're doing wrong installation. Well, the other question is, what are the dominant failure modes of permanent reference electrodes? I think it's in our case, probably could be just the dry out. Probably not that concerned about like the 20, 30, 40 millivolts that shift, but obviously I don't want just to see minus 100 millivolts when my real potential is 700, 800 ohm. Now, we don't have experience with all the reference electrode. We only have experience with this reference electrode, or at least in the past 4 or 5 years. Does your SCADA system have the ability to add the reference offset? Well, I don't know. I don't know if we can do that with SCADA. So well, the thing is, sometimes the information sometimes some of the reference electrode, even the SCADA is failing, and then so we don't get any reading. So this is something I had to find out. Do you have experience with palladium reference electrodes? No, I haven't. I don't have any experience. But they say that it's good for oil, if it's oil contaminated soils, for crude oil tanks. But I don't have any experience. I just saw it from the manufacturer information. No, I haven't used all the brands so far, because obviously the project managers and the asset planners, they say, oh, probably we shouldn't install any reference electrode at all if they fail. But I think I probably would like to see to pinpoint the failure, because obviously that's what technicians say, but probably we need to make sure what the problem with the reference electrodes.
Okay, Raman,
Yep.
that's spot on time, so fantastic. So, yeah, any more questions? Just contact Raman direct, or you can post them up here, and we can try to address them during the midday. It's part of the session, midday break. Well, thanks, Raman. That was fantastic.
No problem.
Yeah, that's really, really good. Thank you again. And I'm sure there'll be more follow-up questions. So we'll move on next to Jim Hickey from Ausgrid. I'll just introduce Jim while we're setting things up. Jim is the Electrolysis Engineering Officer at Ausgrid. He's over 36 years experience with energy authorities, covering electrical testing, earthing design and assessment, and electrolysis corrosion fields. Jim is also chairperson of the New South Wales Electrolysis Committee and is an active member of the Australian Electrolysis Committee and the Australasian Corrosion Association, New South Wales and Newcastle branches. As Ausgrid's ACA accredited corrosion technologist, Jim's responsible for managing the electrolysis corrosion aspects of Ausgrid's electrical network. So another eminently qualified and experienced speaker. Jim will be talking about the New South Wales Electrolysis Committee activities and update us on what's going up in New South Wales in that area. So, Jim, I'll hand over to you and you'll be in control of the screen.
Terrific. Okay, thanks for the introduction there, Bruce. I'll just get my screen set up. Okay. Can you all see that screen? Actually, can you just give me a voice feedback, Bruce? Is that coming up okay?
No, it's just still got your, have you got your video on? You've got stop video at the moment. You might need to restart the video.
I've just got to get out of this. My computer's a little bit slower.
Okay, we can see your face.
All right. Well, this is the one I want to share. Sorry about the delay. It should be just about there. This computer's not quite as up to date as my work computer. Okay, how's that, Bruce?
Yep, all good. You're on.
Right, yeah, very good. Okay, so I'm going to give you an update on the New South Wales Electrolysis Committee, some of the developments and the work that we've been associated with over the previous 12 months or so. We're going to cover some of the interference investigations. We'll touch on some of the regs and guides that are being reviewed at the moment, and some of our recent developments and continuing developing techniques moving into the digital realm. And I'm going to finish off with some of the rail projects that are ongoing in New South Wales, because we're certainly very busy at the moment. So looking at some of the interference investigations that we've been involved with over the last 12 months, the very top graph there is a typical wave shape or waveform from a traction affected structure. And that's instigated a lot of investigation to actually work out where the source is, how it's getting onto the structure, and how to actually resolve that to make sure the structure remains in a protected state. And the two bottom graphs, they're actually interference recorded from CP systems. The one on the very left, the very top red waveform is the foreign structure, the half cell measurement, and that's got an anodic interference on it, as opposed to the primary structure just under it, which has got the cathodic protection. So that CP system is causing anodic interference to our structure. So these are sort of waveforms that we're dealing with, and instigates further investigation. So there's lots of that happening in Sydney, and keeping us very busy. So moving on to some of the regulations and guides, New South Wales electricity supply corrosion protection regulation is currently under view. So that's owned by the Department of Planning, Industry and Environment, and they've been really good with their communication. They've included our committee with this review, and we're working together to try and get some consistency, not only in New South Wales, but throughout the country. Victoria have just recently reviewed their regulations, and we're looking at trying to align New South Wales regs with the Victorian model. So that's underway and going well. We've got the New South Wales WHS regulation. That's a bit of a pain for us at the moment. It's got a requirement to be electrically qualified to actually perform any sort of work on a pipeline or structure that's protected by an impressed current CP system. So that means if you're actually got a corrosion technician going out and taking measurements on your pipeline, for example, or you're looking at coating defect repairs, then these guys need to be either supervised by electrical supervisor or got to be qualified themselves. So this is something that we've taken up with Safe Work New South Wales, and we're actually applying for an exemption to this requirement because it's unnecessary. We've also got an online CPS register, and on the bottom left of the screen you'll see that's a Google Map overlay of all the systems or a lot of the systems in New South Wales. We've got over 1,000 registered systems, and each one of those has an expiry date within 7 years. Some of them are 12 months, some are 3 years. But this online CP register captures all the registration details about the system, the current levels, the registration period, and some of the further details there. So it's a really good system, really good register. And from that, we actually derive our test schedule. So there's an output that we use to develop our spreadsheet, and that's also been improved by some of our members. Sydney Trains are doing a great job there developing our test schedule. So it's going well. And we're also reviewing our guide, as Alan mentioned earlier. It's a good resource, the guide, similar to the VEC resource manual. But this guide, it's certainly due for birth date. So we're reviewing that at the moment and bringing it up to date. Now, some of the testing technique developments that we've been wrestling with, we want to actually move into the digital realm, and at the moment, that's the screen or the waveform capture that we've got on the top left there. The blue one is a rail to earth voltage or rail to structure voltage, and the red one is the actual structure potential, also recorded there. And what we do to actually analyze what's going on here, we actually correlate those two wave shapes together. And at the moment, we're using an analog XY recorder to do that, which you can see in the photo in the center at the bottom. And it produces an XY plot, which you can see on the right-hand side up the top. And we're looking at trying to replace this, because it's actually getting a bit unreliable at the moment, with a digital one. And some of the results are quite promising. But we're still trying to choose the right device for this, because there's a few more parameters and characteristics that we want out of this sort of test analysis. But we are moving in the right direction, so that's going well. Another further development that we're looking at is trying to do a data transfer technique, where if we have primary structures on either side of a major rail line, or even across the road from the rail or whatever. You know, in Sydney, there's large roads, 4-lane highways or whatever, and it's just impractical to run leads to all these test locations. So we actually need remote transfer of data, and we're looking at we've actually developed a data transfer technique, and that's actually working really well. It's given us the opportunity to actually perform correlation testing over 10 kilometres if need be. like we had an issue where we had some interference from a traction system down at Bondi Junction, and that was affecting Sydney CBD. And we can actually use this method to correlate to see, well, it was actually the current or the stray current from the Bondi Junction area. So it's going really well. So that's something to keep your eye on. We'll keep you updated as we further develop this and incorporate it into our new guide for the interference testing. This is some of the results we're getting from that particular technique, the data transfer technique. On the left is the waveform from the rail system, and on the right is the primary structure. Correlating those together, we can actually get a good picture of how the current's actually leaving or getting onto the structure, and to what level. It's proving really good. Now, some of the rail projects, some of the recent ones that we've been involved with, the CBD Southeast Light Rail running right down the middle of CBD Sydney. That particular project we've just recently commissioned, and we're in the final stages of signing off that project. It's actually looking really good. The interference levels are acceptable, and it's a great thing for New South Wales to have such a good light rail in the centre of Sydney. Similarly, the Newcastle light rail, that one we commissioned over 12 months ago. That's going well, and the Sydney Metro Northwest. So this is stage one. So this is the driverless train that's running from Sydney West to Sydney North, and that one has also just been commissioned. So that were three major projects that we've been involved with. The current projects at the moment is the Great River City Light Rail. So that's a light rail in Parramatta. So we're just about to embark on the journey to go through the construction phase and testing, verify that all our assets are still protected and not adversely affected by the light rail. So that one's underway. And then stage two of the Sydney Metro. This is the city to southwest. So it actually continues on from stage one, which runs from Western Sydney to North Sydney. So this one runs from North Sydney around the Chatswood area. It's a new harbour tunnel under Sydney, and then it ends up out at Bankstown. Similar design with a driverless train. And this is a very complex project with a lot of oversight developments and complex earthing systems, and decisions need to be considered in this particular project. So that's exciting for us. And then in the future, we're looking at another Sydney Metro, Greater West. So this will go out to the new airport at Badgerys Creek. So that's in the future, as well as stage two of the Parramatta Light Rail. So there are a couple more projects that'll keep us all employed for the next decade or more, I'm sure. So that's the end of my short presentation. I wanted to try and just give you an outline of what we've been up to and what we're looking forward to. So I'll answer any questions. Audio. Okay. Oh, I've been reminded to mention the Canberra Metro. Well, that's very true. The Canberra Metro, Canberra are now under the, or ACT actually, come under the New South Wales umbrella as well. So we're involved with the light rail in Canberra. So that actually that worked quite well. There's a lot of testing going on there, baseline testing and commissioning testing and further correlation testing. But yes, that was another project.
Okay. Jim, Wayne Burns had a question, but it seems that the panelists can't pose the questions on the Q&A button. So Wayne, if you unmute, if you'd like to ask Jim the question, or has it already been covered?
Hi, Bruce. Thanks for that. I actually had some questions for Ramon, and so I will take them up privately with him. But we have a lot of experience, and we do a lot of R&D with permanent references, and so some of his questions we can answer for him.
Okay. Yep. We can, and we can between 12 and 12:30, we can probably go through some questions as well. Here we go.
Still on the screen.
Yep.
Will Ramon be there at 12:30?
Possibly. Otherwise, if he's not, Wayne, then perhaps correspond directly with him.
Yeah,
There's a question. There's a question from Ray Valdez.
Didn't want to interrupt Jim.
Audio, yes. A couple of questions, or one other. Are we using automatic data collection or manual for corrosion monitoring that we referred to? So we're not quite advanced as New Zealand guys moving into the remote monitoring at this stage. So ours is virtually all manual. However, there are members of the New South Wales EC that do have remote monitoring of their assets. But a lot of the workings that the New South Wales EC are involved with is all manual work. So we get a better feel for what's going on. Like remote monitoring is good to monitor your asset over its lifetime, but to actually diagnose specific issues, sending out qualified personnel is definitely a good way to do it. Peter has asked a question, do we see any effects from Newcastle system? That's an interesting question because the Newcastle system is a little different. Well, actually, it's very different. It's one of a kind in Australia. It's actually an onboard supercapacitor design, whereby the only return path back to the traction substation is a cable from the stops. So there's a charge bar. So all the rail in between the stops is isolated from the negative. And as the tram moves along, it actually has a closed loop current system. So everything's on board. So there's no current that wants to actually leak out of the rails as it's traveling along. And so when it's stationary and the pantograph raises up, hits the charge bar, recharges the capacitor, that's the only time that you could get stray current. And since you've got a really high dielectric insulated cable for the negative running back to the traction sub, it's highly unlikely that you'd actually get any stray current. And when we measured, we couldn't find a thing. It was unbelievably clean. It's probably the best system that we've come across. Very good. Thanks, Peter.
Okay. All right. Well, thanks, Jim. That was that really obviously topical and fascinating. And what we'll probably do is close the official presentations just for the moment. We'll do the AGM of the AEC. Now, the participants, by the way, we've had up to 100 participants, so thanks to everyone for joining in. It's really appreciated. If you do go away for a little bit of a break now, I mean, we'd rather you stay for the AGM and then have a little bit of a break, but 12:30, if you do happen to go away, please be promptly back at your screens so that we can kick off with Richard Brodribb and then Wayne Burns. So I think, yeah, so thanks again, Jim. Now, Ali, are you on audio?
Yes, yes, Bruce.
Okay.
I can have a couple of minutes for the reporting secretaries, etc. Some correspondence, and yeah, I can do that.
Okay, great. So for the participants, anyone that is staying for this portion of the exercise, unfortunately you can't chat live to us, but you can still put up, you can chat or ask a question. So if you want to use your Q&A button, as they pop up, Ali and I should be able to see those, and we can read out and respond as appropriate. But as the official AEC AGM, the first matter that we always go through is apologies. So, and again, if someone has something, if they have an official apology, they can always type it up in the Q&A and we'll just record that. I don't have any from anyone at this stage because we weren't meeting live, we were meeting online. How about you, Ali?
No, I don't have any, especially with this webinar one. So I think most of the people cover. Yep.
Yep. So business arising from the last meeting, the last AGM was at the conference last year in November. I don't think there was any business arising from that. It was pre-COVID-19, of course, so everything's changed since then. But any business arising, Ali?
No, the meeting was the previous 184 was on 26th of November in Melbourne, yep, from 3:30 to 5, and we had 4 speakers: Bruce Ying and Peter Wade and Jimmy Keefe for that. So there is nothing after that. No, that's all.
Okay. Yep. Correspondence and your report.
Yes, we have a few correspondence in the last couple of months. We have people from Electrolysis from South Australia asked to add some new members to be added to the AEC database. Same request from New South Wales. It's pretty good. You can see that now we cover most of the states and representative, especially from electrolysis point of view. We have the main presidents and few other members. So I work with Queensland and a few correspondents from them as well, and also I work with Andrew from Tasmania. Also Richard from ACA Victoria branch communicated with me to organize these sessions, and so far so good. So these are people that they contact us, and at the end of this session I will add my email address to the chat box at the end of it, because I can see when I send a global email to the people, I'll get about 70 bounce back. So people change organizations, etc. So if somehow you don't get my email or you change your email address, please shoot me an email and I can update that later on in our database. Thanks, Bruce.
Okay, that's great. Thanks, Ali. So general business, there's no particular general business other than, you know, this meeting, and what I'd like everyone to have a little think about is that if this sort of meeting has gone well, and if you're happy with this sort of style, we'll be talking about the next meeting, which should be in November, in a few minutes. But of course, the November conference has been cancelled, the ACA conference. So we're going to continue our unbroken run of meetings for the AEC one way or another, and it'll be the 87th meeting. And so we'll discuss that shortly. In fact, as general business, we can always think about this now. If anyone has any suggestions as to whether they would prefer something online in November or in person in November, as well as how you've seen this style of presentation is going. Personally, having face-to-face contact with people is always the preferred option. You can interact with people, you can go away and have a little, you know, chat to colleagues, and that sort of social interaction is a very, very important part of our community. But if there are still restrictions on travel and restrictions in workplaces even, and if it makes it impossible to do that, then we'll do it electronically. But we certainly ask for some feedback from people on what their preferences are and concerns as well. Let's see. Look, any other general business? I know. Oh, hang on, John Grapilia. How are you going over in Perth, John? He says, what about a blended version to enable some others that can't make the trip also participate? Yeah, John, we've attempted this in the past, and it's been quite awkward. But I think in this day and age, with the improvement in Zoom and all the other platforms that can allow us to do this, I think that we certainly should think about, if we do have an actual meeting, a person-to-person meeting where we've got attendees, then we'll try to blend it and make it a bit more easy for people like over in Perth, because I know that we rarely have the meeting in Perth, so that they can join in, and also for New Zealand as well. They have to travel over here, and we certainly have attendees from New Zealand, and it's fantastic to see them come across. But we're certainly aware that it's difficult. So yeah, I think we'll consider that, John. Jeff Cope's just stated there, agree face-to-face is best if we can do it, and I think we still want to do that. But yep, let's make it perhaps a little bit more available for people who can't possibly attend. Candice has said she 100% agrees with John. Let's do both. So Candice, being a high-tech person yourself, you'll be the sort of person we'll call on to ask to help set these sorts of things up. Lachlan's fantastic. I think we can certainly do it and give it a go. Let's see. Okay, so keep those Q&As. Yep, fantastic. Yep, Candice has just said the ACA can support us. And of course, the ACA has always been a great support of our meetings and is certainly greatly appreciated. Okay, let's just move on to, just bearing in mind the time, let's move on to election of office bearers, because we can't get a stack of people to vote. Ali and I will probably be happy just to keep going as we always do. If there's perhaps anyone who disagrees that for Ali and myself to continue in the roles that we are as secretary and chairman, Ali does a great job. I'll certainly nominate Ali to remain as secretary, because he's terrific at keeping in contact with everyone, even though we only have 2 meetings. But it's a lot of effort to get these things up and running, and to chase people up and get people to present. So look, if any, there's another Q&A there. Yeah, both would be great. Agreed. Yep. So unless there's any objections, we'll just list that we are re-elected as office bearers for the AEC. A few nods of heads. Can't see anything coming back saying there are a couple of idiots. Why should we let them keep going? So we'll just nominate ourselves and note that there's no objections to that. And yeah, so the next meeting, and by the comments that have come through, it seems that everyone is very happy for us to attempt to do a live meeting and to really look into having it jointly electronic as well. So we have a bit of a webinar. Those who can get together, great. And if we're allowed to, of course, then that'd be terrific. So I think, Ali, you'd agree with that. We'll try to do that. You might be on mute, Ali.
Yeah, no, that's great. So no problem with that. And then I think at this stage we ask people to, if you want to volunteer yourself for any presentation for the next one. As we see, we have lots of good presentation for different railway project electrolysis activities, which in the past we had lots of papers around different coatings, pipelines. So it seems that railways, it's really branching out in different parts of states, and we have really good paper. But my suggestion, Bruce, is that another topic is around LF5 and earth potential rise, and I think that's a flavor of the month as well. So I suggest that if people can contribute in that area as well for the next meetings, if you have some case study, I know in Victoria there is some work group initiatives happening at the moment under the ESV. So I suggest that if people are interested to have any presentation for LFI and earth potential rise, for next one can be a good one.
Yeah.
Thanks.
Yep. Nope, agree with that.
Right.
Anyone can, yep.
Just on the agenda of how we conduct these meetings, I think we all are agreeable that it's great to be going face to face, but in a environment where maybe there's 10 or 15 other people work for some of these organisations in the field, if they could be participating like this, I think you'd get the benefit of the face-to-face if you can get to the meeting, but you might get a lot more interest by people who A, might be young in the industry, or B, might be field technicians or engineers who can't make the meeting. This gives them a second string to the bow, and I endorse what Candice and John and everyone else is saying, is I think we've got to aim to service remote people who aren't able to make the meeting.
Yep, no, we'll certainly note that one. I think everyone's in agreement, so that'll be good. And look, I think this is this seems to have gone well. It may be different being a what do we call, being a participant compared to being one of us that's on the screen. But we'll get feedback from the participants on that, but I think it's been pretty good so far. Yeah, and everyone's been on time, which has been fantastic too. Okay. Anything else that anyone else on the screen wants to raise?
Yeah, Bruce, one thing that I think is much better about this is probably, I remember in Newcastle some years ago, we tried doing it, and I guess due to lack of bandwidth, it was like really clunky. But maybe now with 4G or whatever, and better network connections, I think this really works well. The latency is really low, and we can handle a lot of conversations at once. So I think it'd be a much improved experience over the last time.
Yeah, great. Yeah, no, thanks, Richard. I agree. Okay, well, what we might do, let's see. So
talk to Ramon for a moment.
Yeah, you want to talk to Ramon for a moment? Yep, sure. Ramon, could you put your speaker back on? You go ahead, Wayne.
Ramon, your presentation was great. I am in the middle of a paper that will come to the next conference when we have one, but we, like you and everyone else, have concerns about permanent monitoring reference cells. We have 7 different sorts of reference cell combinations that are out in the field in 3 locations, and we are logging them on a weekly basis. We want to change the Australian standard, which says that all permanent references that are buried in backfill should be done in bentonite, because we found that with the swelling of the bentonite, it actually precluded water getting to the surface of the reference. So we, like the other manufacturers, we use gypsum bentonite, but we've had some inquiries from one of your fellow countrymen down in South Australia, who's probably been talking to you as well, but whether there's a possibility of this contamination of copper sulfate cells, and we can actually give you a copper sulfate permanent reference electrode with an outer packing on it, which would give you like a double junction reference and eliminate some of the issues. This is only something that our R&D guys have discussed with us in the last 3 weeks. But we are well down the road with a lot of issues that you've brought up, and I'm happy to talk to you further about them. We've been using zinc references for as long as I've been around, and we know that a lot of corrosion people don't get their head around the difference in potentials, but we've found a lot of good performance out of zincs that are prepared properly. not seats where you go down the road, buy a rod, stick a cable on it, not treated and stabilised. So all those things, happy to talk to you. But the issues you're having, the industry's been having them for a long time, and we're also testing as part of the program a number of the overseas manufactured items in parallel. So just if that helps.
Yeah, that's good news. So yeah, we're gonna have a chat offline, so it'll be good. Thank you.
Yeah, okay.
Okay, that's great. Thanks for that. Well, look, if there's no other business at the moment, Ali and I will get back to everyone with some suggested dates. If there's any blackout dates in early November, let's see, October, late October, early November, then let us know. Otherwise, we'll get together and just come up with a couple of dates. And certainly anyone who wants to talk on any subject, we encourage, and no doubt we'll be chasing people up as well. Let's see. And as always, for presenters, it's nothing that has to be published. It's just a PowerPoint presentation, just as we did today. I know it's a lot of work even to get a short presentation up and running, but they're certainly very much appreciated, and the whole corrosion community really looks forward to them. Ali, is there anything else from you? Otherwise, I'll declare the meeting closed, the official AGM.
Bruce, I just put my email address in the chat section for everyone. So if anyone wants to add to the AEC member list, if you don't get the email from us, we usually get a couple of emails during the year. Please shoot me an email, or if your email that list has been changed, please send me an email. As I said, I've got a high amount of bounce back email for that one. Thanks for that. I think that's it. I think we're breaking record for our AEC meeting and also ACA webinar. I think the record was 70, but now you're 100. So that's a fantastic effort and joint venture between us and ACA. Thanks.
Yep, no, that's great. It certainly allows us to reach a lot more people than would otherwise, just attend the meeting. So that's a great benefit. Okay, I'll officially call the AGM of the AEC meeting closed. What's that, 12:55? So that's great. What we'll do is make sure that everyone's here. I'm going to have a couple of minutes break. Make sure that everyone is back here in 5 minutes time at 12:30, and we'll kick off then with Richard. So stay online. You can stop your video or mute yourself, but make sure everything's turned back on and up and running in about 4.5 minutes time. Okay. Okay, well, yep, whoop, hang on. Welcome back, everyone. Ali, thumbs up. Can you hear me? That's great. 12:30, participants 70. I'll just give it just a few more seconds, and then I'll introduce Richard to speak. There we go. Richard's online. How are you going, Richard?
I'm going good. Thanks, Bruce. Thank you.
Yeah, that's fantastic. Let's give everyone a minute or two. Questions and answers. Okay. All good. Okay. Well, we said we'll be punctual, so let's kick off. And I think any latecomers will probably be only a minute or so away. So I'll introduce the next speaker. It's going to be several speakers, but headed first by Richard Brodrib in Brodrib & Co. Bio on Richard, for those who don't know him, which will be very few of you. Richard is the Managing Director of M. Brodrib Proprietary Limited. He's an electrical engineer with over 30 years specialist experience in the design and manufacture of impressed current rectifier systems. He's been responsible for providing cathodic protection systems to the oil, gas and water and infrastructure sectors around, hang on, the bottom of your page is gone. Hang on a minute. I apologise for this. Around Australia and overseas. There we go. I knew there was a piece of paper.
Yeah, thanks for
including recent projects in PNG, Sri Lanka, Russia, Malaysia, and Indonesia. Richard's presently the Treasurer of the Victorian branch of the ACA, a member of the Australian Electrolysis Committee, a life member of the IEEE, and a 20+ year member of NACE. So with that, Richard, I'll let you take over the screen and present your presentation. Thanks, Richard.
Thanks, Bruce. Oops, we'll just try and get that to work. How do we minimize that? Minimize that there. Yeah, okay. Can you all see that?
Yep.
All right. Good.
Just need
our presentation. There's three people making the presentation. That's me, David O'Brien, and Ari Pepe. This will be discussing a large cathodic protection system which had a number of interesting attributes. The customer doesn't particularly want the site to be named, so it will remain as F306. What was this project? It was to replace an obsolete impressed current system, which had been put in perhaps about 20 years ago and was no longer functioning, an old manual control system. It was located in a large pump house, which was partially immersed in river water. The anodes were also being replaced, and they would be done by other contractors. So the scope of our work was to provide a large impressed current system. The CP requirements were interesting. We had to deliver controlled current to about 99 anodes, with currents would range from 0 to 3 amps. The driving voltage had to be 50 volts, which is a bit unusual for a water application because the water was fresh, not saline, and the conductivity was a bit lower. To save money and make it easier to control, the anodes were grouped so the number of rectifiers would be less than the number of anodes. So as you can imagine, some anodes were paralleled, but individual current or voltage control was required for each of the zones. So even though the anodes were paralleled, you had to have discrete control over the zones, like a concrete system, but this was like a concrete system writ large. The rectifiers in each zone had to operate in either constant current or constant voltage mode. The control and monitoring requirements, these were complex. The rectifier outputs had to be adjustable from 0 to 100% of the specified parameter, say voltage or current, from a central control touchscreen, a human machine interface, or we'd call it an HMI, of a type and part number that the client had nominated. So that therefore meant that the software and interface and so on was something that we had to adapt ourselves to for their particular equipment. It had to have alarms for normal and abnormal conditions such as low current and low voltage, and they had to be settable by the HMI. The rectifiers had to be capable of synchronous interruption from the HMI, that is, that they would all turn off and on together. It also had to be able to perform an instant off, a bit different to synchronous interruption, because in this case, you have to switch the rectifier off and then rather quickly read the value of all the references. All the values displayed on the HMI had to also be able to be remotely interrogated by a customer supplied RTU using an agreed data format. So not only was it available on the touchscreen, but whatever was on the touchscreen had to be echoed using a data format that we'd agreed on through the customer to their network. The site requirements. It had to fit into a concrete building which had steel roof supports which came up through the floor. The floor, all the wiring went through the floor plates, but it was not that simple because there was large pump machinery located in the floor and you couldn't move those concrete roofs, those steel roof supports. The building was partially open to river water at the base of the pump, so there's more moisture, perhaps a little bit cooler. It wasn't air conditioned or heated, but it did have a very high headroom, about 10 metres. It wasn't accessible to the public or to unauthorised personnel, so some of the things you might have with public access CP were not such a problem. Ari and David will now discuss how we actually built it. I'll hand it over to Ari.
Good afternoon, my name is Ari and I'll be talking about a few key items. The initial challenge was where the CPR system would be situated on site in the customer's allocated space. Unable to find a suitable location, the CPR was split into two different enclosures, a primary and a secondary. Okay, next one. The primary enclosure measuring 3 meters wide and being the main control point of the system. The features of the primary enclosure included features such as a bottom cavity section for cables underneath, louvering an additional fans thermostatically controlled during warmer days, laptop and document holder, internal LED lighting with door interlock switches. The secondary enclosure was measured 2 meters wide and had the same mechanical features as the primary enclosure. To obtain the required output for the client specification, the primary enclosure was fitted with 15 switch mode CPR modules and the secondary enclosure fitted with 11 switch mode CPR modules. Two sizes for the switch mode CPR modules were used. The larger modules rated at 1500 watts and the smaller ones rated for 250 watts, each with an output voltage rating of up to 50 volts DC. Each module has its own isolated output, but this system called for a common negative. Additional sub-circuits of each switch mode CP rectifier were also required. This made for a total of 98 sub-circuits with individual current monitoring. The individual installation electricians inspected the equipment and were able to provide some additional information on the anode cabling. As such, the terminals were changed to bridge terminals, allowing for terminations of the other cores. This saved the client and electricians time and money on site from having to do rework, thus allowing for easier and quicker installation on site. The primary unit consisted of 59 anode channels and the secondary unit consisted of 39 anode channels. There was also one adjustable and scalable cross-bond connection monitored. This required the design of a new PCB that allowed isolated current sensing. Each of the PCBs allowed sensing of up to 8 channels each. The primary unit, each of the signals monitored from the anode channels were wired to one or more PLCs, with each PLC fitted with multiple analog input modules. The primary unit had 2 PLCs, each fitted with 4x16 analog input expansion modules, and the secondary unit has 1 PLC fitted with 4x16 and 2x4 analog input expansion modules. The PLCs were chosen based on supplier and manufacturer recommendations for minimizing costs during manufacturing, operation, servicing, and life of equipment. HMI panel displayed all of the anode currents and their cross-bond current. Each of the units also had potential monitoring. The potential monitoring was performed by each of the shown PCBs, and each PCB can monitor up to 8 references each. The cell potentials were always being read, and the system can perform an instant off on all the rectifiers to scan and read the references. All of the data, that includes voltages, currents, and potentials, were available for instant download via a USB also. Some of the other challenges experienced during this project were separate schematic styles. That was one for the client versus our in-house style for our electricians to wire to. Our documents for our in-house were typically around 11 documents, whereas for the client it was totaling around 61 documents. The system is also expandable up to another 18 enclosures. And thank you. I will now pass you off to David. Thank you.
Thanks, Ari. So I'm going to talk through the control and monitoring system that we implemented. So Rick's already touched on the control and monitoring requirements, so I won't go into too much detail on this one, but I will pick up on that the client remote monitoring requirements were particular to have a single Modbus device interface, and they wanted it to be read-only, so with a preference to isolate the remote network access from the local network that controlled the devices. So with that in mind, so we had a number of design constraints. So I guess we had several devices with different and non-standard, including a non-standard sort of protocol. So we had a number of different Modbus protocols and a bespoke serial protocol that was particular to the CP controller produced by that OEM. So what this meant was we had no off-the-shelf solutions available to tie everything together. So our approach to this was basically to take a modular approach where we would have at the center of it a variable database that allowed different protocols to update and pull data from the database. And so we sourced a commercial device which was able to communicate on Modbus and a range of other industrial protocols. And then we needed to develop a custom serial client that implemented the CP controller OEM serial protocol so that we could talk to it. Obviously, the key risk in this system would be making sure that we had a robust solution for that custom serial client. So extensive testing was a key feature of what we looked at for this. So check in on a couple of key challenges we had with the serial implementation, which probably no surprise to anyone who's done serial comms. There's a bit of a variation between what was documented in the OEM specs and the actual response of the serial interface. We'll resolve that through, I guess, some degree of experimentation and reverse engineering, combined with support from the OEM to resolve any outstanding matters. The other issue was that essentially the CP controller sometimes became unresponsive when we provoked it. And by that, I mean, we scaled up from 4 rectifiers on the test bench to 26 we had in the full build. So really it highlighted there's no substitute for testing on a full build. But how we tackled the problem was we essentially established in sustainable polling rate. We had plenty of support from the OEM again to adjust some of the configuration settings for the comms. And but at the end of the day, we had to complete test and until we were satisfied with the stability of the comms on a full build. So we extended the testing to make sure we were comfortable with that. So to wrap it up, I guess some highlights of the solution we had there are really around the network segregation we had there, improved cybersecurity, which was important to the client. The customer retains control of all their data. So this solution we have here is not dependent on an OEM cloud solution for the client to access the data. The client can keep it as closed or open as they choose. The interface we had for the client is quite flexible, so we can reasonably readily configure that for other protocols, be it DNP3 or MQTT or a variation of Modbus. And we have a reusable solution to translate between the CP controller and a range of the industrial protocols. So in what we've built, we can scale that up to 60 rectifiers. So thank you for your time. And what questions do you have?
That's a Jeopardy thing.
Okay, so there's nothing's come through on the Q&A just yet. So I'll have the question. Is the system up and running at the moment? Is it been delivered and commissioned?
It's been delivered, Bruce. It hasn't been commissioned yet at all. It went through pretty big factory acceptance tests, but it hasn't. It will be commissioned in about 6 weeks' time. So yeah. I'll turn Jeopardy off. Hang on, if I can. Well, we're there. Yep, good.
Yep, yeah, we can still see and hear you.
Yep.
Okay. And I missed on the, so it's an indoor unit.
Yep.
Is it air conditioned in the building?
No.
Okay. Yeah.
No. There's
what sort of ambient do you expect?
it's southern Australia, so it's fairly. I mean, I don't think it gets tremendously warm. There's plenty of roof space.
Okay.
So I would be surprised if it got above 35 in the building. I don't know, but it's not sort of really stuck in the middle of the desert.
Yeah, and dust and so on.
Mm.
Okay. Right. How about others? I mean, I find the progress in the electronics and stuff, and certainly the communications is pretty extraordinary certainly over my career. I still like to keep things. I like simple things because I'm just a simple-minded person. But do you see any complexities there that you would change if you had more control over the original specification?
I think one of the issues more is a question of properly understanding the specification between consultant, manufacturer, and client, because things can be interpreted in different ways, things like resolution and response rate and so on. I think we didn't have any problem with that. It was just a question of discussing it. Because CP is not an incredibly fast process, it wasn't someone was saying, "Oh, gee, you should have read that. Why didn't you give me the voltage back in 10 milliseconds or whatever?" I think that because of the particular application, I think the specification was pretty suited to it. It's a big piece of gear. I mean, it would have been nicer perhaps if we'd have had more space, but the client already gave us more space than we'd originally been given, which made it more wireable. I think, as Ari was saying, from a manufacturer's point of view, if you get these tiny cabinets, they really can be hard to work on, and you get everything shoehorned in, and then some poor devil's got to fix it, and that could be me. So that's the end of the world. So
yeah. Okay.
No, sorry.
You go on. Yeah. What's your comment?
One thing I think that we're seeing more and more with anything that's internet connected is this requirement for cybersecurity. Though, like not only in our area here in CP, but in say battery charging or anything else we're involved in, that people are saying, how safe is my system? And I think that was interesting for us to start delving into that as to how to make something which was not essentially open to the outside.
Yep. Okay. All right. Okay. So no more questions through on that, but I love seeing these things.
Looks like there is one more question there, Bruce.
Is there? Oh, hang on. Q&A. I've got. Oh, the term of cross-buy. Yes, sorry. Yeah, David Anderson Smith said the term of cross-bond current was mentioned. Can you please explain what this is?
Ari, can you give a talk on the cross-bond current, please?
Yeah.
Yep.
Yeah. No, thanks, Jim.
The question is, what was the cross-bond current?
Are you there?
Yep.
Hello?
Yeah, so Ari, the question was, the term of cross-bond current was mentioned. Can you explain what this is?
I'm not too sure what it was. It was the customer said it was going to be some type of current that was going to flow between the two negatives of the two units. So as the units were split into different areas, they're expecting some current to flow, yet they weren't able to say about how much. So as I said, it is actually scalable. So they can scale up the current reading anywhere between 13 milliamps up to 50 odd amps.
Okay. Right, and look, there's just one more question, and then we'll move on. Reiko has asked, how quick was your instant off requirement? Milliseconds, 10 milliseconds, 100 milliseconds, and
I'm not sure.
Do you have to provide a single?
Off the top of my head.
No, and do you have to provide a single off value or a decay array?
It was, what I remember is we took it at a predetermined time, but no, I'm not sure of that myself.
Okay, okay.
Yep.
And it was just a single instant off value that you're after.
Yeah, so it turned off. We waited a second or so. Well, I'm not sure the exact timing. And then we took a reading. But the idea is that you get all the readings at the same time every time you perform the test or the interrupt cycle.
Yep.
Instant off.
Okay. Yep. Yep. Okay. No, good. Oh, it'll be interesting to see a follow-up paper or presentation on the commissioning.
Yep. Okay.
Okay.
No problem.
All right.
I'll hand you
fantastic.
back to Richard then.
Okay. Thank you.
Okay.
All right. Yeah. Well, I'm going to close him off in a second anyway. So thanks. Yeah. Thanks, Richard, and thanks for Ari and everyone for that. Very interesting. We'll move on. Just a couple of minutes over time, but that's fine because we've only got one more speaker, and that is Wayne Burns. Someone's just reminded me on the Q&A there that he has over 50 years experience, which is in his bio. So I'll just read Wayne's bio for those who don't know much about him. Wayne Burns is Managing Director of Anode Engineering Proprietary Limited. He's a metallurgist with 50 years experience in CP and related industries. His experience is across pipelines, petrochemical plants, above and below ground storage tanks, wharves, jetties, as well as all forms of ships, boats and marine structures. He's a life member of the ACA, as well as an active member of NACE, APGA, Marine Surveyors Association and the World Corrosion Organisation. He's an ACA and NACE accredited CP lecturer, a member of the ACA Foundation Board. The Anode team identified the spiralling costs of conducting CP surveys in remote locations and have developed a green amp daisy chain data DCD monitoring system. So this is what he's going to talk about, that also interfaces with their green amp remote monitoring and control of remote CP systems, where conventional mobile data does not reach and satellite communications are expensive. So I've basically just given his talk away there, but I'll hand you over to Wayne. And Wayne, you're in control of the controls. Wayne, you need to turn your microphone back on.
Yeah, I'm on.
Yep, and you're in control, mate.
There you go.
So
Okay. I'll just bring up the somehow we've got our talk.
That's it.
Okay.
And start the show and you're away.
There you go. Thank you, ladies and gentlemen, and Bruce and Ali and everybody. I'd just like to preface this in that we have spent our life, many of us and many of the people listening today, driving up and down pipelines, spending hours driving and minutes testing. And as such, this development we took on a couple of years ago was born out of the limitations that we have with conventional comm systems, as in mobile networks, and the expense of the alternative of satellite communications. And so we've come to a point where we think we've got a workable remote monitoring system, which we refer to as daisy chain, which will come out as we go through the presentation. So many of the pipelines we're located and working on are in remote areas with regulations for annual reports outlining the state of the pipeline, maintaining licenses for them, etc. In recent years, the workplace is changing. Safety becomes one of our paramount concerns, and for many of our clients, safety is becoming a more expensive item. The on cost of doing a survey now with all the H&S issues is probably double the cost of what it would have cost us 15, 20 years ago. We estimate around this country there's over $10 million spent on CP surveys every year. We drive vast distances, and this has proven to cause fatigue and rising incidents of accidents and things like this. So relatively, clients are getting to the point where access is becoming an issue, and so we are getting hostile farmers who don't want us driving through their paddocks. You've got to get 2 weeks' notice to get access to land. All these things are raising the cost of doing surveys. On top of that, you're in a remote location, and rightfully so, the farmers have got concerns about the spread of Parthenium weed, long rat-tail weed, and noxious weeds generally. This is causing us to have to drive sometimes an hour back to town after we leave a property to go and get a certificate and a wash down for the vehicles, so we don't spread the weeds to the next property. And all of these things are becoming an expense that the pipeline owner's got to incur. And the big issue we're getting from the owners is it's not just the expense of this, it's the extra driving time, the potential of more accidents and more incidents. So we then decided that, well, on top of that, we have these issues with the weather, and especially in North Queensland and Northern Australia, where floods come through. It's difficult to get in and out of properties, so the weather is becoming another major concern for us. And so the annual survey regime that we currently use really just gives us a snapshot of the pipeline at that time when we go through. And over the years, we've seen incidences where the change in the time of the day that you do the survey, the weather condition, solar systems that don't function at night and might have flat batteries that you don't see during the day, all of these things are becoming a pain in productivity. Hence, we believed it was time to find something else to do and do it a little bit better. So our solution to this is 2 to 3 years ago, we put together a team of programmers and electronics people to try and find an alternative to what we're doing. And in that sense, the standard green amp system we've developed measures the pipeline potential at every test point once every hour, or you can have it test every second or tenth of a second or half a second. But the general program we run runs it for every hour. We record the data. Every 24 hours, it sends the data off to our cloud, and we use that through the Internet of things like Cat-M1 system, the NB, and the IoT cellular connections where they're available. We say this because a lot of folks are saying, oh, we just use the mobile network. The Cat-M1 system is a data network, and as such, it has a coverage that's at least twice as big as the standard 3G, 4G coverage you will see on your mobile phones. So we are finding we can get a lot of network connections, so we don't have to use satellites and the others. But then the other issue we addressed was where there is no cellular coverage, right? The green amp uses a thing called daisy chain data. And this is basically, it collects the data at each test point and it sends the data to the adjacent green amp system or test point, and they daisy chain the data down till it finds an outlet where it can send the data out of, such as a Cat-M1 network or whatever. And the range typically, we're saying we go 5 kilometres between test points. We've actually gone like 10 kilometres in some really fairly rugged country, and we still got the data transmitting. But we try and restrict to go sending data no more than 10 daisy chain links. And that's simply that there's data transmission time. The intelligence of the green amp daisy chain system is such it waits for that one to come through, then it sends the 2 of them, then it sends the 3 of them, then it sends the 4 of them. So there is a data time which we think it becomes uneconomic on battery life after you go past 10 units. You might say, well, how does it know to go upstream or downstream on the pipeline? The program is set such that it goes through the learning and teaching process itself through the program, and it goes looking in both directions. And so when it finds the best direction, it'll preferentially send it that way. If there's a malfunction, it sends it the other way. And then if there's a malfunction halfway along, it can actually jump over and bypass one of them if one of the systems are down. And so we think we've covered most operational issues as we go down the road. So the data is then uploaded to our cloud where cellular or Wi-Fi is available out of network, right? We use standard batteries that have a life expectancy of 5 years, but we have an option where we can put rechargeable batteries in and put small solar panels. That would be utilised predominantly where you are in traction system areas or something like that, where the frequency of testing might suit you to be once every hour. You might want it once every half a second or whatever. So to change the program, we actually, at the end of the 24-hour transmission, it looks for instructions from the internet that we control or you control. And so you can tell it to change the parameters. And then once it's gone through that change of maybe 1 hour, 2 hours, or 3 hours of recording, it then defaults back to the old program that's set into the system when you buy it. Right? The other building communications protocols include Wi-Fi, 802.11, BGN, Bluetooth, Sigfox, etc. So we think technologically we've covered most of the things we're looking for. Right? We provide a secure website portal, and that looks after the data, so we can either on-forward it to you along with warnings and alarm systems, or you can have it go to our engineers and we can then interrogate it, prepare a report, or do whatever. Just keep in mind, when you've got the report once a year and you start getting this once every hour, you can go into information overload. And so data management is something else that we will offer you if you decide you want to go down this road. This is a typical graph. We've got a number of portals which gives us different data. This is a time frame at one location. This is actually a field test we did with the client system. And you would think out in the remote that things would be fairly normal. What happened here was that the potentials changed, and this is a zinc reference cell that we were using as the datum. And what happened is the potential there shifted in an anodic direction overnight. And we thought, this is a bit strange. And then we went back and we were actually recording the rectifiers, amps and volts and operational conditions. And it was strange that this also coincided with a wet period where we had a lot of storm activity, which we get in November in Queensland. So what we determined is we went back and saw the client and said, well, what's going on here? You've got a solar system in the area. It's on auto potential, but the potential is going positive. It was still well protected, as you can see, like plus 250 is the criteria. We're down here at minus 400. But what we determined was that the batteries were malfunctioning on the solar system and it was struggling to maintain the data potential through here. You would not have seen this had you been there once a year and had you not been there in the middle of the night when it was pouring rain and thunderstorms. So this is the sort of information that I think is probably the future of management. These are some of the other portals. This is a GPS map you would see where we send you from the internet. You get green ticks where everything's okay, and a red tick where anything is malfunctioned or outside the criteria, be it too high, too low. And then from here, you can click on these, and as you can see, you can get the data as a drop-off for this particular presentation. As you interrogate further down into the data, you can get the potentials of the structure, how much it's protected. There's GPS coordinates, and there's time frames, there's alarms, whether it's healthy. The things you can't do generally is you can't edit this stuff once you get it on the portal. because obviously this can be used for reports for people who want to know that your structure is still protected. So there's any number of options that you can have, right? But then once we got the single channel version operational and we were able to do a whole lot of things, we decided that we should have something that we can do with the rectifiers and the CPU units, the solar systems and the mag anode bits. So we now have available what we call the Green Amp 4 Plus, and it's a 4 Plus because it has 4 channels plus a separate circuit to control a contactor. The contactor can then turn the system on and off, so you can program your rectifiers or your solar systems or your mag anodes to start switching, and they can come on at a certain time, come off. They're all GPS synchronized. So you can monitor current, right? I'm getting ahead of myself here. You can monitor the thing turning on and off down to half a second if you want. You can pre-program this. You can monitor amps, volts, pipe potential, foreign structure potential, right? And you can then also have the 5th channel, which is the contactor relay that turns the system on and off. Again, this thing is established such that you can set it to do this for a certain time frame and then default back to its normal operating conditions. But there are a lot of sacrificial anode systems around where it's sometimes difficult, and you spend a lot of time driving up and down pipelines, putting interrupters in and doing all these things. We're now at the point where the industry will probably make portable interrupters a redundant necessity. This is a map that we've had from one of our clients, and they basically said, look, you know, we want to try and monitor this system. So the green notations are actually where we can get Cat-M1 coverage, so we can upload from these sites, right? And then the purple ones is where we don't have any coverage at all, and this is fairly, as you can see from the map, it's fairly rugged country. So these in the middle would then be DCD transmissions. They'll DCD transmit either north or south to this Green Amp system here, which has Cat-M1 coverage. So it'll pick up this lot and send it to there. Or if you wanted, you can just have the whole lot go somewhere up this way and take it all out. But this is the programming that's taken us quite some time to hone it down to a point where you don't have to go Green Amp DCD, but where you are in really remote places where there is absolutely no issue, no coverage at all, then the Green Amp is the way to go. Your 4 Plus M1 here, these are rectifiers or sacrificial beds, and so we can synchronize these, send the programs down, and away you go. So that's a fairly brief summary of what we've done and where we're going. We aren't at the point where we don't think it's necessary at this time to be able to control the set point on the potential of the rectifiers. We're also aware that there are issues that the cost of satellite communications is extremely expensive, but the future is low orbiting satellites are not far away, but data transmission is going to be a limiting factor. But our history has been try to be there for the future needs of the nation and globally, and from there come up with the answers. So we hope we've come up with some answers for reducing the cost of doing all this stuff and reducing the number of people in the field, reducing issues of accidents, health issues, helicopters and everything else. So that's it. Any questions?
Sorry, because I'm part of the panel, I cannot type it in. Wayne, Thanks for the presentation. Just a quick one. Any issue with the calibration of the reference for the data loggers and stuff? How do you manage that?
The references are a totally separate issue. And as I said to Ramon earlier, we have so many questions that our clients and you, the marketplace, are asking. We don't have a major problem with references, but I've got to say we're biased more towards the permanent zinc reference electrodes. I am emotional about people buying a zinc rod or a piece of galvanized pipe, stick it in the ground and call it a zinc reference. We go a lot of trouble to prepare, etch, calibrate and prepare a zinc reference. We hate with a vengeance bentonite because we actually tested some references packed in bentonite, because that's what the Australian standard says, and that sock was wet on the outside, and after 2 hours it was still dead dry at the reference. We then went and soaked it for 8 hours, still had a dry patch around the reference. We've replaced it with standard gypsum bentonite and a much better performance, because the bentonite is meant to expand and block up holes in drill stems and things. So we think, well, it's part of the paper that I'm presenting at the next conference, but we will have results that confirm that one shouldn't use bentonite as a backfill around your reference. And, you know, we've followed this standard for some time, but we're saying to clients, look, you know, you need to and go from there.
Yep. Wayne, there's a couple of questions on the Q&A. If you can't see those, I'll read those out to you.
Yeah.
Yep. So Ray Valdez has asked, yeah, please comment on the software used to store and analyze the data. And we better wind up in a couple of minutes too.
Okay.
So,
the data is stored for 5 years on the Green Amp systems, and it's transmitted to our internet cloud, where we store that on the cloud. So from there, we also have programming that the data that comes in, if there's alarms that have to be sent, you tell us the alarms, you get an alarm on your phone or however you want. We think we've covered it pretty well on that.
Okay. Yeah. Great. And David Anderson-Smith's asked, are there any particular requirements for interfacing with existing TRUs? And then there's one question.
One thing we've done is we've gone away from monitoring the current through shunts, and we've got another bit of electronics that allows us to monitor the current without going onto shunts and things. And to be honest, that's not just a plus for that, but with surge diversion and shunts being a channel for where you can get current surge coming down and blowing things up. Our current monitoring is pretty much independent, and it's a good unit.
Yeah, okay. And final, we'll make this the final question. Timothy Holmes has asked, are there any other data types that you'd like to capture at monitoring stations?
Absolutely. This is just the beginning. We see that, like we're monitoring battery voltages on solar systems as well. We see the temperature and humidity might be something. We see gas flow. We see corrosion probes will be the next interface we have, and that's the monitoring of, you know, well, the standard probes, the ones you get from the 2 or 3 manufacturers around the world. And so, you know, there's no limit to what you can do, but right now there's millions of dollars being spent doing once-a-year surveys and costing people, in some cases, small systems, a lot of money. And we just think that this is it. All I'll say in closing is you don't have to buy these systems. We also have a leasing arrangements over a 5-year period. So, you know, when you're looking at a whole lot of these things, we believe that this will be an ongoing development that over the next 5 years, we're just going to be at the cutting phase of it.
Yeah, well, certainly the electronics and the communications via the internet, there's tremendous advances being made, and as far as monitoring, or as most of these talks have shown, it's really continuing to be a growing part of our industry. All right, well, I'd like to call it quits on the meeting at that point. I'd like to certainly thank all the panelists, the presenters, for well, I found it fascinating, every single one of those. Thank the participants. We had up to 100 participants up there, up to about midday. It was fantastic. I'd like to thank Lachlan at the ACA, the Vic branch of the ACA, who've been very supportive and have greatly assisted. And without Lachlan, we wouldn't have been able to get this up and running. It would be otherwise like a family Zoom meeting where people are all over the place. So look, thanks again to everyone for participating and for joining in. Ali and I will work on the next meeting in November, and I'll leave it at that. So thanks again, everyone. Look forward to seeing you post-COVID-19. Cheerio.
Thank you.
Over that.